1 2 1 2 1 2 1 2 1 2. Woo! So now we're going to be testing out to see if to watch this also happen in our debugger tool, to see how the find path finds the path of a this thing and of a node and what it returns in essence before moving on. So we are going to just create an instance of find path. Now we pass in the root, which is the head, which is A, to find path, and then we pass in the node which we are looking for. Now the interpretation of 8 is going to be T. So let's see how that transverses. So we're going to do a print blah 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 blah. Yeah, so we are going to see what that prints for us. So save. So let's call our debugger too. Okay, let's enter into this. Now we can now go through our stuff. So we've entered into the find path, and we have our two values. We have our roots at index of A and the node, if I'm not mistaken, where should it be here? So index of D. So we can now go transversing. So now we hit our checker. You can see that our direction list is empty. So we go to the checker and we pass in the root, and then we enter into that. And now we see for the first instance, we check if the current is none. So current is obviously not none. We can see that the 3 is pointing to something. So that condition cannot be satisfied. We then go ahead again to say current is null, is node. You see test if a 3 is balanced. So we check whether these two guys are the same. Obviously we could see from here that they are not, because when we look at our current is A, and the node we are looking at is D. So basically from the values we could see they're not the same, so that guy is not going to be satisfied. So we append L to this guy. So immediately we pass through this guy. Now we will see that L is updated on, which is the left, it's updated on our direction list, yeah. And then we call checker again. So we enter into a new stack, and you can immediately see that our current changes to B because we've gone to B, this guy over here, right here. So we see that we go to B. Now while we are in B, we check again if we are none. It's not none. We check current is equals to whether B and D is equal, which is not true. So we go again, we update our left, and we go to the left. Now we see B immediately update to D. Now these two guys are equal, and we now check again if these two guys are true. Now you can see that here it will return true, and basically immediately returns true. It propagates that back up to B. So we see that we're in B now. The stack has gone back from D back to B, and we've returned true. And now checker again will return true and also push us back up to A. And we are at A, we go to continue and return A, and basically we return true on our checker. So our checker should be true. I don't know if we hold that anywhere here. So we see return checker is equals to true. So because now we've returned true, what it simply means is that now we can also go ahead and return what our directory basically. So yeah, so we can go ahead and return our um, directory. So basically this shows a flaw in the code immediately, because we see that if this also return false, we still go ahead to return our direction without anything stopping it. So basically we have a flaw here, which we can say, which we say if checker. So we have to say if checker, right? So that's when we return true. Else basically we could return an error saying this thing. So return an index error saying this is not found, node not found. So yes, so basically this is ideally what should happen, because the checker wasn't, it was just returning false or true by and then meanwhile updating the directory, the direction, but actually not stipulating whether we return the direction or we return an error to say, oh, this direction was not found or this node was not found. So that's an update that was made by reading this. And yeah, so now we could go ahead to now look at how this transverses. But basically what we need from here, we've seen it. We see how the find path updates this guy and this guy simultaneously, and basically returns us the value of, or basically the direction. So the direction we take from the head of the node to the node that we are looking for, basically. and that's what we try to get here from this find path instance.